All right.
Can we get our own notes or like
Just for today, you'll have to finish this lesson, then I'll have it
I
for you.
thought we did.
No. All right, so yesterday we started this and we talked about symmetry as far as what symmetry looks like. So now what we need to do today is talk about, okay, how do I algebraically test for symmetry? Because most of the time I'm going to ask you to do this and not give you a graph. So the process really is pretty simple. And I tried to lay it out so you can see that it has symmetry. So, as we talked about, there are three types of symmetry: x-axis, y-axis, and origin symmetry. To test for them, you simply put a negative in for the opposite variable. So if I want to test for y-axis symmetry, I replace all x's in my equation with negative x. If I get my original equation back, it has y-axis symmetry. If I don't, it doesn't. So I gave you a really simple equation, y equals x squared. You put negative x in for x, negative x squared is still positive x. So I got my original equation back, so that tells me x squared has y-axis symmetry. Does that make sense?
Hold on, I was one of those. I'm actually confused. That doesn't make it sound any better.
No, not really. You're striking on your butt.
No, I meant.
I knew what you meant.
Sorry, look at those. Why do you want to say look at those?
My mom calls me that.
Told you what?
Doesn't show me.
What?
My mom calls me that.
A lot of people call me that.
I think I call you that because that's what Carrie didn't call you.
Need some like music in here.
So
All right.
settle back on me.
I'm not writing.
You're not even saying no.
So the second one, okay, the second one, x-axis symmetry. Again, you replace the opposite variable with the negative of itself and solve. If you get the same equation back, it has x-axis symmetry. So I replace y with negative y. If I get my original equation back, it has symmetry. If I don't, it doesn't. This equation does. X minus y squared equals 1. If I plug negative y in for y, I get x minus y squared equals 1. I will tell you, x-axis symmetry is the least common of the three. And a lot of that has to do with the vertical line test, because it has to almost be sideways. And with the vertical line test, a vertical line can't pass through your graph more than once, so you run into issues there. Yeah.
I'll wait.
Okay. Lastly is origin. With origin, you replace both x and y with negative x and negative y and solve. And if you get the same equation back, your original back, when you do that, then you know it has origin symmetry. So 2x cubed minus x is an example that has origin symmetry.
So for that, it'd be negative y is equal to
2 times negative x cubed minus negative x. Yep. Yep. And then you would solve it back into y equals 1.
Wait, so what was that? Negative x equals 2 times negative x to the
No,
third.
negative y equals 2 times negative x to the third plus x. And then you solve that back.
And you should get this.
Then if you solve that back and get y by itself, you get that exact same equation back. After you do the power.
So you should end up with just.
Covert operations.
I'm not.
Why is it not appropriate? Well, it's better done.
Yeah, I think you really have to follow the order.
Getting my entertainment comes in. I just look at that. I'm still waiting for me. It's fine. Keep going, please. Maps, let's map.
Alright,
No, that's not good about
I mean, I'm kidding. Wow.
okay.
Origin.
Okay, y equals x squared minus 2x plus 1. Yep. And we need to see what type of symmetry does this equation have. Now, it is possible for an equation to have more than one type of symmetry. It's also possible for an equation to have no types of symmetry. So you have to test all three all the time.
Let's just check. When you're checking for y-axis, you have to replace x, not y.
Yes. It's the opposite variable.
That's gonna be confusing.
So, if I try and do y-axis symmetry, y-axis, I put negative x in for x everywhere x is in my equation.
That won't change. That won't.
And I solve this equation. So I get y equals a negative squared is positive, so that's just x squared. Negative times a negative is plus 2x plus 1.
There you go.
Is that the exact same?
No.
No. So does it have y-axis symmetry? No, it does not. And you can simply just put no.
No.
I do the same thing with x-axis. So I get negative y equals x squared minus 2x plus 1. Divide by negative 1. I get negative x squared plus 2x minus 1.
That ain't it, chief.
That's not the same either. So what do I have left to test? Origin. So for the origin, I put negative y equals negative x squared minus 2 times negative x plus 1.
That ain't gonna do that.
So I get negative y equals x squared plus 2x plus 1. Divide by the negative 1. Y equals negative x squared minus 2x minus 1. Does that problem then have symmetry? No.
Wait.
So what you would do there is you would say the equation x squared minus 2x plus 1 has no symmetry.
What does that equation look like?
It's a parabola.
Or it's quadratic.
It's just an off-centered parabola. Crosses at 1.
So technically, it's still symmetrical, like to itself.
But not to an axis.
Okay.
Gotcha.
Yeah, that doesn't mean the graph itself isn't symmetric as far as shape-wise, but as far as to an axis or an origin, no.
Is there another example?
So what?
Is there gonna be another?
Another example. Yeah.
If it's symmetric to the origin, it can't be symmetrical to anything else, Joe.
So what?
No, it's not gonna have symmetry to the y.
No, if it's symmetric to the origin, it can be
Y
symmetric to the origin.
Y. So you can just say
That's
right away.
Well, but the y-axis is that whole imaginary line. So it could be, even though it's not at 0, 0, it could still fold on itself, just up a little bit.
Like at like 3.
Right. Do you get what I'm saying? Because it's a hot dog fold.
Yep.
Now, you're right, because it's up at 1, there's no way it's gonna have x-axis symmetry. Right.
So really the only way it could have X would be if it had like plus nothing, if it didn't have anything after that.
That's possible, but usually it's gotta be turned this way, because it's gotta fold upon itself this way. Imagine. So it's gotta be sideways almost. Yeah.
So to solve them out, you divide by 1.
-1.
Negative 1. What about the top one?
I just work the negatives out. So you just negative x squared, that becomes positive x, negative times negative is positive, and you're done. So you just get rid of the negatives.
Why'd you put a negative Y?
Here,
Yeah.
because that's the rule. You replace y with negative y.
Oh yeah, it is the rule. I'm a dingleberry.
Okay, second, here, why don't you try this one? Try this one on your own. Do the 3 tests.
Can we do it on a calculator now?
No, gotta do it by hand.
Why don't we just do it by mind? So if you place X.
No, you can leave it just as is. You don't have to move it.
Oh, we can?
Yeah, you can move it to y equals if you want, but I would just leave it. It's way easier if you just leave it.
Oh, it is easier.
Oh, wait, come here. This is all I have to do.
Okay, so it's X equals 1. Well, you don't offer Y axis. Place on the Y is negative. So X is 3.
Is that the same
Negative
as
X.
what? I know.
Or just get a
You're trying to
more.
compare it to the original. Are those equal?
No, it says to get more, right?
Because it's a negative.
Why is it original?
So it's not same. So you just say no, you can do it on the equation.
So they're literally all.
You sure about that?
Okay, so you're saying.
Wait,
One of them is yes.
Is
Okay, so-
X-axis?
I don't know.
That's
I go through it.
So when you get to this, then you have to divide everything by -1.
X minus.
You know, I did not do that. So if I have a negative.
X place on X equals negative X.
Why did they do the X? How is one yet?
Sorry.
Because it's usually how negative Y.
So is that the same? Is that the same as the original?
Woohoo! I did.
No, right?
I did.
Then you just go on to y, you make a y, you do it, and then simplify and see, is that the same?
Okay.
Negative 30, negative 50, positive.
Claire's at
Well,
work.
but remember, you replace the y with negative y.
Is that-
Parentheses come before add subtract, so a negative squared would come
Oh,
before
okay,
add
but
subtract.
I
So you actually add something.
So it's
So it's
going to be positively negative Y at the end of it.
So is that one the same?
Yeah.
Then the origin, so that.
You put-
Alright.
and minor.
Okay, so let's go through this.
It's X-axis.
So y-axis symmetry.
No, it's not like this.
So I replace x with negative x. Someone asked, well, is it that simple as to look at it here? Yeah. Is that the same as the original? No. Pretty simple.
Well, how would you solve that though? You have to divide everything by -1.
Yeah, you have to put it back in the y equals form, which is why I said just to leave it alone. That way you're not. Alright, I need your attention. Being on your phone's not an option.
G.
He's not the only one.
Go.
Okay. Now, put the negative y in. You have to put it in parentheses because parentheses and exponents come before add and subtract. A negative y squared becomes a positive y squared. So this becomes x minus y squared equals 1. Is that the same?
Yep.
Yes. So you know it has x-axis symmetry. So now we just gotta check for origin. Negative x minus
You already
Good luck, watch.
No, you already have it.
equals 1.
Once you
So
write negative X, you're done.
is that the same?
No.
So this problem only has x-axis symmetry.
So we need to find or prove that it's only one or two.
Yeah, so it could be 1, it could be 2, it could be all.
Okay, realistically though, once you did the y-axis.
Yep.
You
know
figured
origin is
out
not
that the
gonna work.
origin wasn't gonna work.
In this specific
In
case.
this one, yeah.
There are times where the X doesn't work, but the origin does. So you have to go through it. All right. Okay. Last thing, last concept, finding intersections. This is the last part of P1 here. So you have two options to find intersections. The first one is to sketch both graphs and find their intersection by making an XY table. Okay? To me, that's the long way of doing it. But you can do it that way. The second way is to do it algebraically. And if we're doing this algebraically, that means we're solving a system of equations. So if we're solving a system, you have two options. You have substitution and elimination. Those are your two options. Substitution and elimination. Okay? I try and do elimination as much as I possibly can, because that gets rid of a variable and makes your life 10 times easier. But that's not always an option. So to do it algebraically, you're doing solving systems, which means you're doing either substitution or elimination, like we said. Okay? Good?
Just wait. Just a second. I'm sorry.
Kyle, if you have a baby, can you like bring it into class?
That's not how it works.
Do it.
I think you can.
I mean, I probably could, but
Not for like 8 periods
It
a
was
day.
Very annoying.
You only have to worry about
Doug, just bring it in for us.
You're probably needs to wait a little bit.
Yeah.
You don't
Wait
have
till
to
you're
pay
like
us.
8 on its own.
Just take it off your salary.
You have a name picked
Free
out yet?
childcare. Yeah,
Childcare.
for giving us free education.
Sorry, nobody gives you anything.
You have to pay
so-
tuition.
The only thing you're ever gonna get for free. That's a lie.
All right.
Hours of work.
last thing. Oop, I didn't leave an example. Oh,
That you literally don't have to do anything.
oh, you weren't done.
And
Okay.
but literally, they do like $1,000 if you go to Nutmeg. So you could register for that. Then drop out.
All right.
It was pretty funny.
No, it's just.
You need to do, no, did you see this?
Yes, got it. No.
Are we good? No, we got one example. All right.
Elimination.
Yeah. This one's actually gonna end up being substitution.
Yeah, that's why I thought it was even funnier.
I remember doing this, I think.
Okay. Last thing we have to do is find these intersections. We go through this example and we'll be done for the day.
Only one example?
Just one. Yep. So you actually can do this problem by either substitution or elimination. It doesn't really matter. So if you choose to do elimination, you are looking for a variable that is either the same or opposite. Is there a variable up there that is either the same or opposite? The y's, right? They're both negative y. And this is where, if you remember from Algebra 2, same sign, subtract, add opposites. When you're doing systems, same, subtract, add opposite. Same, subtract, add opposite. So these are the same. So we're going to subtract. So x squared minus x just becomes that, x squared minus x, because you can't subtracting, let's say, the same power. The y's will cancel. 3 minus 1 is 2.
Is this substitution?
This is elimination.
Isn't this where you draw that thing and then you put numbers? You put a number up on the box and then they draw a line.
No, that's a different thing. That's synthetic substitution.
Oh, it's synthetic elimination. Is there elimination for that too?
Just synthetic and polynomial. Long division. So, I now have a quadratic, so I move the 2 over. And now I can factor. So this is a simple AC problem. It simplifies to x minus 2, x plus 1. I know I skipped a couple steps there, but it's a pretty simple factor. So it's negative 2 and 1. So if I solve this, I get 2 x-intercepts at x equals 2 and x equals negative 1. But it wants intersections, which means an x and a y. So what do I have to do with those 2 x values? Plug it back in and solve for y. You can pick your equation, it doesn't matter. I'm going to use the bottom one because that's the easier of the 2 to work with. So I've got x minus y equals 1. So I've got 2 minus y equals 1. So y in this case is just going to be 1, because 2 minus 1 is 1. Everybody see that? Okay. The second one, negative 1 minus y equals 1. I get negative y equals 2. So y equals negative 2. So my 2 points then are 2, 1, and negative 1, negative 2. Now, could you also do that by substitution? Yes. But if you're going to do that, you then have to solve for one variable, plug that into the other one, and then you're going to have to FOIL. It makes it a mess. So whenever you can, try and use elimination. Okay? And that's it. So you have the last, there's about 8-9 minutes left or so left.